All right, so we are going to review a little bit of stuff before we get any farther. And so let me see if I can make a decent looking. I don't guarantee that this is going to look great, but I'll do the best I can. You got to pretend like it's centered, okay? So I think it's kind of centered, right? A little bit better? Okay, we can pretend. Okay. So if I give you if I want to plot a point on the angle that is pi thirds, what quadrant would I be in? Pi thirds. Pi thirds, I'd be in the first quadrant, right? And would I be closer to the x-axis or y-axis? Y. I'd be like up here for pi thirds, right? So this angle right here, this would be like pi thirds, okay? So what would a coterminal angle for pi thirds be? Okay, let's review what coterminal means, because you're just yelling numbers out at me. Coterminal would mean another way, like another name for me to actually get to that exact same. Like this is pi thirds. How else can I get there besides going pi thirds this way? I can go a negative what? Right? This is pi thirds, yes? So this would be a negative what? Negative 5 pi thirds. Make sense? So I either get here by going pi thirds this way or negative 5 pi thirds. Yes? Make sense? Okay. That's called a reference angle. So we'll talk about reference angles here too. That's a good question. So what about 3 pi fourths? What quadrant would I be in? Second, that's for sure. Okay. So second, and I'd be like right here, right? So this right here would be 3 pi fourths. We agree with that? Okay, so what Tony was asking about, the reference angle would be the quickest way to the x-axis. That's pi fourths, right? And so that's why we talk about it as our pi fourths angle. This is our second quadrant pi fourths angle. Make sense? Okay, so what would be a coterminal angle for 3 pi fourths? Negative 5 pi fourths, right? Make sense? Okay, so what is our fourth quadrant pi fourths angle? 7 pi fourths. Make sense? So you know what I mean when I say I want my fourth quadrant angle and whatnot, right? Because we need to be able to think about coterminal angles. This is your reference angle, which pi fourths, so this is a pi fourths angle, but then also what your coterminal angles are. So I want you to think about, I'm going to give you, let's see, 7 pi sixths and 7 pi fourths. Okay, so I want you to think about it for a second, and I want you to give me coterminal angles for these two. So just think on both of them for just a second. All right, so Eddie, you said you got the first one. What's the coterminal angle for 7? Come on. Good. 7 pi 6 would put me right about here, right? And then negative 5 pi 6 would also get me there. Make sense? Okay, who wants to give me the second one? Oh. Go ahead. Negative pi fourths. Yes? Okay, we good? So we're all clear on the whole coterminal. Any questions about that before we move on to this other stuff? Okie dokie. Good deal. So then let's get on to these notes here, which I knew I'd forget what the page number was, 126. So it's going on page 126 when we are done. We are going to look at the polar coordinate system. So this is a whole different way to graph points. It's a whole different coordinate system. That's why it's called the polar coordinate system. So we're going to draw this little x and y axis here. So because we are used to x and y, you've been using x and y axis like forever, right? So if I plot this point here, and this point is at 2, 2, right? So you've been plotting points like forever. And you should have been able to plot the point 2, 2 for a long, long time now. And so to get to this point, the way we plot it is we start at 0, 0. We go to the right 2, right? And then we go up 2. And that's how we get there. We agree with that? So you go this, you do your x, and then you do your y. Could I get to that same point by doing the y first? Yes, I could have gone up 2 and then to the right 2. That doesn't matter, as long as I don't switch which one's x and y, but we always just do x and then y. That's just the way you do it, right? So that's how we plot that point. No big deal, been doing it forever. So if I connect that the origin to that point is a distance away from the center, right? How far is that point from the, not from the center, from the origin? How far is that point from the origin? Yes, it is r, but specifically, so good job. It's, well, more easily than Pythagorean theorem, what kind of triangle is that? Right triangle. What kind of right triangle? You're trying to say Pythagorean, but it's an isosceles right triangle, yes? Isosceles right triangle. So what's this angle right here? 45. No, we're trying to find it's a 45, 45, 90 triangle. So what's the hypotenuse? It didn't take you any work at all. Somebody said it over here a minute. It's not 2. Can't be 2. Oh. How do you find what's your rule when you have a 45, 45, 90 triangle? It's one of your special right triangles. Remember for 30, 60, 90, it's S, 2S, S squared to 3. For 45, 45, 90, it's L, 2. Yes, L squared to 2. So it is 2 squared to 2. That is this length. It's a 2 squared to 3. And I thought I heard somebody over here say 2 squared to 2. That's why I said, yeah. So you can do Pythagorean theorem, but you don't need to because it's just that, okay? Now, that's not it. That whole process, thank the Lord, because nobody remembers how to do it, is not really part of what we're doing right now. But we did need that link for me to talk about what we need to talk about. So, usually when we plot the point, obviously, we're not worried about 2 squared to 2, right? That's not part of your plotting process. But if I want to plot that exact same point, there's a completely different way for me to be able to get there. If I am, again, we're just looking at the x and y axis that we already know and love. Instead of getting an ordered pair where I have to go to the right 2 and then up 2, if I swing out and I get, like, I'm here at 0, and I rotate here to get to what I know is a 45-degree angle, right? So we, like, rotate it up. And I know I have rotated 45 degrees. Then from the origin, if I go out a distance of 2 squared to 2, then wouldn't this point be in the exact same point as the other one? Does that make sense? But instead of worrying about what this length is and what this length is, instead you worry about the rotation and the length of the radius. Does that make sense to you? Now, that might be a harder way to graph this specific point, but it's going to make some points way easier depending on what we're doing. So what I want you to understand is, yes, our coordinates grid is going to look different. All that stuff's going to look different, but we could still plot the exact same points we're doing either in what's called the rectangular coordinate system, the x and y axis you know, or the polar coordinate system. And there's other ones besides that, okay? And why we need it and what we're doing with that, I'll make sure I'll show you all of that stuff. We're just going to need to learn how to do it first, and then I'll help you make it make more sense, okay? Well, yes and no. There's some things that we do with this, and the answer is no, but there's not really that much stuff here necessarily to memorize. Okay, it won't be that bad. All right, so it's just understanding that it's different, and once you kind of wrap your mind around that, it's really not that big of a deal. So it says, up until now, you've graphed on a rectangular plane containing an x and y axis. Like, that's what you're used to. It's the Cartesian coordinate plane, the xy coordinate plane, the rectangular coordinate system, all that. We will now look at another system called the polar coordinate system. So here's how you form a polar coordinate system. X and y axis, a rectangular one, you just do 2 intersecting lines, you got your 2 axes, right? That's different here. So instead, we fix a point O. So here's our point O. And this point right here is called the pole or origin. So it's still the origin, but really you call it the pole most of the time. Okay. From O, you construct an initial ray, which is like on the which would be like the positive x-axis part of that, and it is called the polar axis. So where in the rectangular coordinate system you have 2 intersecting lines and you basically have 4 rays coming off the origin, the only axis you have is this one ray right here. That's it, okay? And then each point P, so here's a point P, in the coordinate plane is a polar coordinate r comma theta. So instead of x, y, it's r theta. Remember the length of the radius and the angle I had to rotate. So r is the directed distance from O to P, and theta is the counterclockwise directed angle. Okay, so you're worried about the angle and how far you are from the pole. Those are the two things to get those points. We good? I'm going to give you a rule for what happens when r is negative. And when we first get a negative r, then we'll use the rule and I'll show you, but I'll show you a different way where it's not something where you have to memorize a rule. It's understanding a concept. So there's a couple rules I'm going to show you, but the second one especially, we're not even going to talk about how it works. I just want you to know that there is one, but understanding the concept and how it works makes it way easier and there's no memorizing. So when r is negative, and I know you don't even know what to do when r is positive yet, but when r is negative, instead of plotting a negative r comma some angle, then we graph the point r comma theta plus pi. Okay. Now remember how I asked you when you graph a point on the rectangular coordinate system, we always do x and then we do y. You know, we go left and right, then we go up and down. But we could go up and down and then left and right. Like it'd probably be weird, but we could still get to the same spot. So here, even though this is r comma theta, we don't usually start with the radius. You can, but most of the time when you are trying to figure out ordered pairs from an equation, what you're substituting in is an angle. So you almost treat your angle like your x. So we do the angle first, then we worry about the radius. It makes everything easier. So I'm here on this coordinate system. This is what it looks like. This is my grid. So it's circles because we're rotating instead of, you know, little squares because it's x and y and it's rectangular. Notice that this is your polar axis. Pay attention to the scale on this axis because every radius is a half, not one, okay? So there's two for each one. And that'll change on some of them, so just be careful with it. And it's harder because on the x and y, like we'll have this numbered and that numbered and that numbered, and so if you're over here, you can find the numbers easily. If you're over here, you can't see the numbers, so you have to kind of go around the circle so you don't get off on the grid. It makes it weird. Okay, so here's 0. And we're still rotating. See, most of your angles are on here. So we're at number 1. A is 2, 7 pi 6. So we're going to go to 7 pi 6. We rotate around here, 7 pi 6, right? Then from the origin or from the pole, you want to go out 2 units on 7 pi 6. If you need to come back to where this 2 is and follow it around, you can do that. And then boom. There's your point. This is point A, yeah. I especially do because I'm standing off to the side and this grid looks weird. Either that or I have to stand in front of it sometimes so I can make sure I'm in the right spot. Easy enough? So I rotated around to 7 pi 6. I'm 2 units away from the pole. We good? All right, so I want you to try and graph number 2. Try and graph B, and then I'll talk you through it, but just see if you can make sense of it already. Well, the pi-4ths angles aren't on there, right? But should you know where they are? Yeah, you should. That's right.
Oh, yeah, so I know it.
Okay. So I'm here. I'm going to rotate around to 3 pi-4ths. Here's my 3 pi-4ths. It's between the pi-3rds and pi-6 angles, right? And then, so here's 3 pi-4ths, but from the pole, I go out half, and I'm right there. That's B. We good? Yes? Easy enough? All right, so let's look at number 3, because number 3 gives us a negative angle. That doesn't necessarily make it any difficult. That's not a negative r, that's a negative angle. So I'm here at 0. I'm going to go a negative pi-3rds. And then, so negative pi-3rds is the same as positive 5 pi-3rds, right? But then I need to be 3 units away, so that's 3 units away there. It's point C. Okay. Everybody okay with that? Any questions? All right, so on number 4, we're going to do the negative 1. We're going to talk about it with the rule, but then I'm going to show you a different way that makes it a little bit easier. So I go to pi-4ths, right? Bam, here's pi-4ths. So it says when r is negative, because I have a negative 1, I'm actually going to plot a positive 1, but I have to add pi to the angle. So what is pi-4ths plus pi? 5 pi-4ths, right? So instead of pi fourths, I have to add pi. I come around here to 5 pi fourths, and I go 1 unit away, and there, right there is D. But here's the thing. The 5 pi fourths, the actual value of that doesn't matter, so I don't actually need to add it. Notice how, look at what's happening here. This is my 5 pi fourths that we ended up at, right? And this is pi fourths. Yeah, it's not coterminal, and it's not, yeah, it's the other side. So we're talking about the radius. Do you see how it's on the same diameter, right? And isn't this just half the circle, which is 180 or pi? So instead of trying to add it, instead, the way that most people graph this and make it a little bit easier is if you go ahead and go to pi fourths, but since it's a -1, you pass through the pole and do 1 on the other side. Does that make sense? And that by doing that, since it's on the diameter, you really are adding pi. I know, I'm sorry. Okay. Get it? Watch it. I'm going to throw it at you next time. All right, so does that make sense? So that's what I mean by pass through the pole. I still go to pi fourths. That way I don't have to worry about adding anything. I pass through the pole to 1. So try and do number 5. Plot E, or I'm going to throw my pen at you. Yeah, do number 5. And be careful, it's so easy when you pass through the pole to like end up on the wrong angle. So at least think about the fact that when I rotate around here, I'm at 4 pi thirds, right? Since I'm going to pass through the pole, I need to make sure I'm still on my pi thirds angle, and I'm going to go 2.5 away. So let me get in front of it so I can get this right. So this is 1, 2.5. And right there should be E. Because I just graded a quiz from my other classes that there were some people, I think what happened is that they knew what they were doing, but when they passed through the pole, they like just went over a little bit, and it's easy to kind of, so be careful with that. Because it's hard to tell if you don't know what you're doing or if it was just like a little mistake like that. All right, so 6 has a negative angle and a negative radius. See if you can graph that one. You can do it. So I'm at 0. I go negative pi 6, which takes me to 11 pi 6. I pass through the pole to get a radius of 3, and that is F. We good? Now remember, each one of these points, if I took a rectangular coordinate system and I superimposed it on top of this, I could plot those exact same points with different coordinates. Obviously, the coordinates would look different, but I could still plot those same points. And we're going to learn how to convert between polar and rectangular. Okay, so we'll take a point that's in the polar coordinate system. We can convert it to rectangular, so we could graph it on an X and Y axis and end up in the exact same spot. Okay, we good? Questions? All right, so let's look at what else we're going to do with this. It says, while each pair of polar coordinates plots a unique point, each point does not have unique coordinates. That means that I can get to each point an infinite amount of ways because I can just keep running around the track, right? If we're all out on the track, we're all standing in the same point. Some of us run an extra lap. We end up in the same spot, but, you know, our coordinates would be, our system would be different. So here's this. I'm going to give you this rule just because there is one, but I really don't like this one, and you'll see why when we write it. So here's how it works to find the other ones. You get r comma theta plus 2 pi n, which should kind of make sense, right? Because it's just the same thing, but you go around again, and you go around again, and you go around again. Or negative r comma theta plus 2n plus 1 times pi. So y'all can either remember that stuff, and maybe you're a formula person. The majority of us are not. Like you see every formula you see, you remember it, and you can apply it. Most people's brains don't work that way. So I doubt that that's going to be your go-to way to do it. Instead, understanding the concept is going to be way better. Right? So it says name 3 different pairs of polar coordinates that also name the given point, and we're going from negative 2 pi to 2 pi. So the first thing that you should do is get an idea of where this point is. Now, we're not graphing it perfectly or anything like that. Just tell me what quadrant is 5 pi thirds in. 4th quadrant. We agree with that? So that means it's about right here. right? And the radius being 2 doesn't matter on my little picture. I'm more worried about where the angle is. And so then I need to come up with 3 other points. So there's going to be another point that has a positive radius. So I can get to this point by going a positive 5 pi thirds and a radius of 2, or I could go a negative what? Pi thirds. So a radius of 2, angle of negative 5 pi thirds would get me to the exact same angle. Does that make sense to you? Then I'm going to have 2 more that have a negative radius. So negative 2 is my radius. So what that means is where I need to land with my angle would be right here. Does that make sense? So I have to land here so I can go a negative 2. Make sense to you? So what would this angle be? 2 pi thirds. So I can go 2 pi thirds and then a negative 2 for my radius, and I'll be in the same spot. Or negative 4 pi thirds. So each time you do this, you will have 4 points in the end, including the one they gave you. You will have 2 positive radii, 2 negative. So what I do, and it doesn't matter what order you do it in, but if they give me a positive, I do the other positive and then the negatives. If they gave me a negative, I do the other negative and then the positives. It just makes more sense to me. And then look at the 4 angles. Ignore the signs. Do you see how you have all of the pi thirds angles? Does that make sense? 2 are positive, 2 are negative. And they won't always be the same system of signs this way, but what it does tell you is that if you have a negative 4 pi thirds and a positive 4 pi thirds, something's wrong because it doesn't double up. Okay? We good so far? Questions? Say that. Right, exactly. Yeah. And that's why the picture helps, so you can kind of get an idea of where you are. Otherwise, if you're just trying to picture it in your head, it gets confusing. All right, let's do one more together, and then you're going to do some. We do. All right, so here we are, and we're going to get an idea of where our point is, right? What quadrant is this angle in? What quadrant is negative 7 pi fourths in? That's in the first quadrant, right? But I have a negative 5, so my point actually ends up over here. Does that make sense? So I'm here, I go negative 7 pi fourths, and then a negative 5. Okay? So there's my point. And then that means I'm going to have a negative 5 radius one, and then I'm going to have 2 positive ones. Go ahead and set all that up. So I got here. I actually landed here with my negative radius, right? Because I went in negative 7 pi fourths, negative 5. So if I'm going to stick with the negative 5, how else can I get here? Positive pi fourths, right? Okay, so remember, this is my actual end goal. So now I'm going to have a positive radius. How do I get here with a positive angle? 5 pi fourths, good. And how would I get there with a negative angle? Negative 3 pi fourths. Ask me questions if you got questions. Anything? Mm-hmm. Because I'm trying to end up here. To get to the third quadrant for my pi fourths, I'd have to go a negative 3 pi fourths. Yeah, because this is where I'm actually ending up. Like, this is my actual point. So I have a positive radius, so it's negative. I'm going there. At this point, whatever this point is. Yes? Okay. All right. Y'all do number 9 on your own. I'm going to give you a minute. Draw where it is. Think about where your points are. Let's see what we got. Okay, you have that one twice. You have that angle twice, and it's not going to show up twice. How are we doing? Good. No. No good. Okay. I think maybe we need to talk through this. All right, so here's where my point ends up. I go pi 6 and then a negative radius, so I end up here, yes? Okay, so if I'm going to have a negative radius again, that means my angle has to end up here for me to use my negative radius. So I don't care what order you did these in. Like some of y'all didn't do this one first, and that's fine. Like if you did it last, but it still has to be negative 1.5, I have to end up here. To get here, I would go a negative 11 pi 6. So a negative 11 pi 6, and then a negative 1.5. Does that make sense? You can totally have two negatives, yes. Okay, now you know. Okay. All right, so does that help? Go ahead. Now, if I give you a second to do the other two, would you be good? Okay. Fix the other two then. Let me double check myself here before. Yes, good. No, you have them backwards. Yes. Let's talk through the other two. So to get here directly, this is going to be my third quadrant pi 6 angle. So coming here, this would be a positive 7 pi 6 and a negative 5 pi 6. Okay, does that make sense to you? Good? Okay. Ask me questions if you got them. Oh, yeah, absolutely. Yes. And actually, that's what they gave us right here. They gave us that one. Okay. How did I get this one? Okay, because I'm trying to get here directly. So if my radius is a positive 1.5, I would have to go a negative 5 pi 6 to get there. Okay, does that help? Okay, good. Anything else? We're all good? Okay, so we're going to stop here for today. Oh, go ahead. Okay. Uh-huh. Yes. You go like across the diameter, which means if I'm in the first quadrant, if the angle gets me here and the radius is negative, I pass through the pole and end up on the other side of it that far. Okay, so yes. Do you see how this is if I took pi 6 and I subtracted 2 pi, I'd get this.
Yeah, look, so these kind of go together.
Uh-huh.
If you both have a negative, then this one you'd have to go around back to
Yes.
pi 6.
Yes. Yes. So yes, they do, because the 7 pi 6 and the 7 pi 6 and negative 5 pi 6, these are the coterminal angles that we were asking about. That's what I'm saying. Yeah, which one's negative? Yeah. Yes, good job. Yes, absolutely. Because that's how you get a coterminal angle. Yes. Yes, okay, so the question was, once you get this, can you just know that this one is, because these are both positive, can you just know that this one is negative and make sure that they equal up to 2 pi? Well, yeah, that's how you're getting it. It's this minus 2 pi gives you that. That's why they're coterminal, because this plus the absolute value of that would give you 2 pi together. Yes. Yeah, and that formula, but that formula with the ends and the plus ones is just kind of weird too. But the concept of the formula that way totally works. That's a good question. Okay, anything else? Yes. You might want to wait, because I'm going to give you one on the homework we're going to work on. So I'm going to give you the assignment. I'm going to tell you which ones, well, just don't do the distance, basically, because we'll talk about distance tomorrow. But I want to talk about one of these on here, and then you'll have some time to plot. Don't cross out the distance ones, because we are doing them, and they're easy. We just don't have time to talk about it. Okay. Okay, so I want you to, on the assignment, I want you to look at number 2. Tell me what freaks you out a little bit about number 2. 7 pi 12ths. And oh my gosh, it is not a mistake. Okay? All right, so 7 pi 12ths. 7 pi, it is a little bit more than pi halves, and that's good. 7 pi 12ths. Okay, so if we're talking about this, we would talk about our pi thirds angles and our, pi sixths angles, right? So we also have pi 12ths angles. Pi 12ths is how much of pi sixths? Half, okay? So if this is pi 6, right, that means this is pi 12. Do you agree with that? Okay, so the line's there. Now that's 7 pi 12ths, but like Eddie just said, what is it? A little bit more than pi halves, because if you think in terms of 12ths, remember how I taught you to think about like this is 3 pi thirds, that's why this is 4 pi thirds? So if this is 0, this is 12 pi 12ths, right? And this would be 6 pi 12ths, that's where you get pi halves from. So one more, that gives you 7 pi 12ths. Make sense to you? So if this is 12 pi 12ths, this is going to be 13 pi 12ths. See how that works? Like, so think if you can think fractionally, you can do any of these no matter what number I give you. Make sense to you? You're not going to get anything weirder than a pi 12ths, but you should still be able to reason around the circle with it. Okay? We good with that? Questions? Well, this would be, so if each one is pi 12, so this is 1, 2, 3, 4, 5 pi 12ths. Plus, look, this is 6 pi 12ths, so you back up 1, 5 pi 12ths. That's not what you... This angle right here, it is 5 pi 12ths. That's really what it is. Yeah, because it's 6. Yeah, because the other one's reduced. Like when I call this 6 pi 12ths, it reduces to pi halves, right? And even this, I could call it 4 pi 12ths. Well, that's pi thirds. This really is 5 pi 12ths, and it doesn't reduce. And this right here was what? 3 pi 12ths. That's where your pi fourths comes from. Okay, so good question. All right, so you should be able to, you got like 10 minutes left. You should be able to plot these and get some of these done. Now, we didn't do one with degrees, but it's just degrees. Get over yourself. Okay? Figure it out. You got this. Okay? Well, thanks. I'm here all week.